Okay, graphing practice. Graphs are actually pictures of the data that you collect during an experiment. So you need to have a data table to be able to construct a graph. Now in science, most of the graphs that we make are actually line graphs because they show trends in things. For instance, this practice problem here, number 1, is showing the age of a tree in years, and then each 10 years, the average thickness of the rings in that tree. So every 10 years, they took the average of the 10 rings for that decade and recorded it. After 20 years, they took 11 through 20 and took the average there. They did it for the trees in Forest A, and they did it for the trees in Forest B. Okay, so we need to graph these two forests and the average thickness. So first thing that you need to know when you are making a graph is what the independent variable is. And the independent variable is what the experimenter is manipulating. The dependent variable is what they're measuring. So in this case, the independent variable is the age of the tree in years. And usually on a data table, you're going to see the independent variable in the first column on the left. The dependent variable is the average thickness of the annual rings. So it's in centimeters. All right, so let's go down to our graph and we'll practice setting up a line graph with this data. So here is your graph. And we did this one in class. We didn't do the whole thing, but we did most of it. Now, on a line graph, the independent variable always goes on the bottom of the graph. So on a graph, it's usually shaped like an L, and it has grid marks on it so that you can plot your points more easily. Not all line graphs you have to do on graph paper, but it's easier to plot your points. So on a line graph, this is the x-axis here on the bottom. It's called the x-axis, and the y-axis is here at the top. So the independent variable always goes down here. Now in this case, the independent variable is the years or the age of the tree. Age of the tree in years. All right, so let's look at that. The age of the tree in years. They did it every 10 years, up to 60 years. So we need to make the most of our graph here. We need to make the most of the graph by making our increments occupy as much of this line on the x-axis as we can. So looking at that, probably the best thing to do is make each hash mark or grid mark worth 2 years. So you got 2, 4, 6, 8, 10. That's 10 years. 12, 14, 16, 18, 20 years. 22, 24, 26, 28, 30 years. 32, 34, 36, 38, 40, 50, 60. Okay, so the x-axis, we've got it, the IV labeled, we've got the years labeled. Next thing we need to do is label the y-axis. Now the y-axis again is the dependent variable, and in this case is the width. You always write upward like this, width of annual rings, and you want to put the unit. The unit in this case is centimeters. So we're going to put the unit here like that. Now we have to think about how we're going to number the y-axis? Well, if you look at the data from Forest A and Forest B, it goes up to about 4.5 centimeters is the widest. So what we need to do, again, we'll start at 0 down here. We'll make each hash mark on the grid worth 0.2. So we have 0.2, 0.4, 0.6, 0.8. There's 1.0. 1.2, 1.4, 1.6, 1.8, 2.0 centimeters, etc. So we'll go all the way up to 5. 2, 4, 6, 8. That's 3.0. 2, 4, 6, 8. That's 4.0. 2, 4, 6, 8. And then 5.0 up there. Of course, yours will be much neater than this because I'm trying to work this on the smartboard. Okay, the next thing we need to do is we need to graph this data, plot our points. So if we go to the data from Forest A, we will see that at 10 years, right here, the average annual thickness was 2.0, which is right here. So what you do is you take and you go up from 10 and find where it intersects with 2.0 and you plot your point right there. So that's the first point. Okay, you're not going to leave those lines there. Okay. All right, at 20 years, it was 2.2. So we need to go at 20 years. We need to go up where it intersects with 2.2, make a dot there. Again, don't mark, use your finger. I'm just showing you with this how to come up with the point. Okay, at 30 years, it was 3.5. So you go up, and then 3.5 would be right there. And then at 40 years, it was 3.0. So that would be, we go up 3.0 right there. And then at 50 years, it went up to 4.5, which would be up here. And then finally, at 60 years, it's 4.3, which comes back down to about there. Okay, so there are your points plotted. Next thing you need to do is connect your points. So we'll start at 10 years. Connect, 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 connect. So there is, so what you want to do is, since I used green, make a little key. I used green. I'm not sure if you can see the color, but I used this for Forest A. Then you're going to go back, and with another color, you are going to do Forest B. So Forest B at 10 years, it was 2.2. At 20 years, it was 2.5. Oops, I made that dot over there. The first one wrong. 2.5. And then at 30 years, it was 3.5, which is a 3.6, which is a little bit above that one. At 40 years, we had 3.8, which would be right there. And then at 50 years, it was 4.5, which would be, no, I'm sorry, it's not 4.5, 4.0, which was down here. And then at 60 years, it was 4.5, which is a little bit above there. Okay, so connect your dots. Okay, come over here, forest B. Now the last thing that you need to do with this is give it a title. Now the title is going to be the independent variable versus dependent variable. So at the top of your page, I don't have much space here, but you're going to put independent variable age of tree versus average annual ring size, and then centimeters. So there's your title on there for that one. Okay, I'm going to go ahead and help you get started on graph number 2, graphing practice problem number 2. This one's a little bit easier because there is only one dependent variable column. All right, so what we have here is they're trying to see how the pH of the water, that's how basic or acidic it is, affects the number of tadpoles that are there. So again, the independent variable is over here. Here, it's the pH of the water, and the dependent variable is what they measured, which is the number of tadpoles. Pretty easy. Okay, so now we'll go down and set up our graph. So you should again ask yourself, what is the independent variable and dependent variable? The independent variable goes on the x-axis again, which is there. This line is the x-axis. And the independent variable is the number, the pH of the water. Now, in this case, in the data table, they did it going down. The first piece of data in that data table is 8. So you should be, while you're listening to me here, you should be looking at the data table. So the pH starts at 8, but it's always good to start with 0 down in the corner, the bottom left-hand corner of your axis. So we're going to have to plot our data kind of backwards. So the highest pH we have is 8. So why don't we, if we have 33 lines, to get 8 on it, I bet we could do every 4 grid mark equal to 1. Okay, so if we did, I'm sorry, every grid mark equal to, we're going up to 8, so and there's 33 equal to 4. So if we went 1, 2, 3, 4, we made that 1. And then 1, 2, 3, 4, that's 2. And that's 3, 4, 5, 6, 7, and that's 8.0. Okay? So there would be our x-axis, except we need to label it, and we're going to label it pH of water. Our dependent variable, again, is the number of tadpoles, and there is no unit here, it's just the number of tadpoles. There's no measurement, it's just an number. Okay, so let's look at our data. It goes, the highest number is 88. So if we make each line 2, I think we might fit it in there because I think there's 43. Maybe we ought to do 5. Let's do 5. Okay, so we did 5 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so there we have that label. Now it's real easy. You just have to plot your data. So if we do the first row, a pH of 8 has 45 tadpoles. So we start out here, pH of 8, go to where it is 45, and come up. You're going to plot your point right there. Erase the line. Okay? So your first point is right there. Okay, at 7.5, there are 69. Well, where's 7.5 here? Well, it's right in the middle. It's right there. So there are 55. Here's the 55 line. Here's the 7.5 line. Plot. Again, you don't want those lines in there. So we did that. Okay, next is 7 and 78. So 78 is right about here. Right there, plot that point. And then we've got 6.5 and 88. 6.5, 88 is way up at the top here. Okay, and then 6.0 and 43. 6.0 and 43, we're coming back down to here. Whoops, that might be a little, yeah, that's right, 6.0 and 43. And then 5.5 and 23. 5.5 and 23 would be right about there. Now we have no data for these points, so we're just going to, for this part here, there is no data. So we're just going to connect this way and go in order. So we're going to go here and then back down there, there to there. So it's kind of like a curve that way. It's a little sloppy, but the last thing that you need to do is you need to give it a title, which is the independent variable pH of water versus dependent variable number of tadpoles.